Alright, I think we live everywhere. About to do another coding challenge. You know what time it is. Friday night. I'm running a little bit behind tonight. It's like 10:30 here. But I'm gonna try to get this in. I'm gonna try to do this every Friday, like I said. So I'm not about to start missing them now. So we about to do another medium problem from KG.codes. This one's called Maximum Number of Vowels in a Substring of Given Length. That title even long, so you know this one gonna have a little bit of trouble to it, I think. But I just did it earlier. It took me a little bit of time. I'm not gonna lie. It took me probably an amount of time of a hard problem, because I haven't done a problem like with a solution like this in a while. And yeah, so it took me a little bit of time to figure this one out. I eventually figured out at least the unoptimal solution myself, and then the optimal solution I had to look up. So tonight I'm going to do this problem with just the optimal solution. Before I got on here and I did the inoptimal solution, then I did the optimal solution, and it just took so much time. Like it took like 2 hours. I'm not about to go through all that. I'm about to just go through the problem and go through the answer, and that's pretty much it. And then maybe answer some questions at the end. But other than that, yeah, I'm going to get started. I'm live everywhere. If you want to jump to another platform, Instagram, TikTok, X, Facebook, Twitch, YouTube, I'm everywhere. So let's get started with this thing. This is maximum number of vowels in a substring of given length. It's a medium from KG.codes, and it goes as such. Given a string S and an integer K, return the maximum number of vowel letters in any substring of S that has the length K. And then vowel letters, of course, are A, E, I, O, U. And I guess they're not including that sometimes Y thing, so we can just kind of rely on it just being these 5 English characters, lowercase. And then they have an example here with A, B, C, I, D, E, F. And the length of the substring they want us to look at is 3. And the output, the maximum number of vowels in a substring of given length is 3. So this takes a little bit of understanding to try to understand what they asking for. Like they basically looking for, they got K here, and they're saying like if you're only looking at substrings of size 3, so like ABC, BCI, CII, III, IID. If you're only looking at substrings that have 3 letters in them, what is the maximum amount of vowels you can get with all the different possibilities of 3 character substrings, if that makes sense? And so in this one, they're saying your substring is 2, so you can look at AE, you can look at EI, you can look at IO, you can look at OU. The substring is 2, but what's the maximum amount of vowels you can get for a substring of that size in this string? So it's basically telling you, look at all the combinations of substring of size 2 in the string and tell me what's the max amount of vowels you can pull out of it. So in this case, all of these are vowels, A, E, I, O, U. So the maximum you can get is 2. Like in any of these 2 substrings, they'll both be vowels, so you'll get 2. And then let's look at this last example called KG.codes. The substring length is 3, so you can look at these 3, or you can look at these 3, or you can look at these 3, and so on. And what combination in here will give you the most vowels? Well, the most vowels you can get is 2. That's in leet, you can get the 2 E's. You can get the 2 E's, and then in eat, you can get the 2 E's, and in ode, you can get the O and the E. So yeah, that's what they're trying to get you to get. And then they have some constraints here. You know, if you're in an interview, or you will know if you're in an interview, that you might get these constraints, you might not. You might have to ask for them. Like the size of the string itself. So the size of the string that we're going to be looking at will never be more than 10 to the 5th power. So I don't have any worries about like this overflowing or something like that. The constraint, it'll always be 1 character, so I don't have to worry about like the empty string case. And then S always consists of lowercase English characters, so that's cool. I don't have to deal with any symbols or something like that, or any uppercase characters. And then here, K is always going to be it's always going to be at least 1, and it's always going to be less than or equal to the length of the string itself. So that's a good, because you don't have to check for any kind of like errors with the input. So basically it's saying is you're always going to have some sort of answer here, and you don't have to check your input too much based on these constraints. But you might get this in an interview, you might not. Like, you might ask this stuff and they say, hey man, like, they might tell you, yeah, you could just assume that it's always gonna be perfect, or they might tell you, hey, you need to cover the case when this is null, when S is null or something like that. But it just depends. So if you watched me do these before, you know how I like to do these is I like to talk through the solution first, and then I like to take the approach, at least how I would do it in my head, and I like to take that approach and try to apply it to kind of data structures and algorithm stuff that I know. And so when I'm looking at this, I mean, what screams out if you've done these problems before is, I'm not even going to say what screams out. I'm just going to just look at it from just trying to do the problem wise. Like, when I was reading in the examples here, you can kind of see how to solve it. Like, you know, you got a size K, which is the substring size. So you know you need to look at each substring in here of size 3 and figure out how many vowels you have in each one. So in ABC, I don't have any vowels. In BCI, I have 1 vowel. In CII, I have 2 vowels. In III, I have 3 vowels. So that's the highest I've ever seen. So let's take note of that. And then in IID, I have 2 vowels. And then you can see the rest of the string. I don't have anything that'll ever be higher than 3 vowels. So I know my output is 3. And so if you start doing these problems enough, what that kind of screams, when you're looking at a string at like substrings of a string, and you're kind of like sliding through it like this, it lends itself to like a sliding window technique is what they call it. It's a particular type of algorithm that you can use to basically look at a window, quote unquote, inside of a array or a string to basically figure out your answer to your problem. So you're kind of looking at a certain window at a time inside of your string or your array or whatever it is, and you're doing some sort of algorithmic logical operation on that substring to figure something out. And a lot of these problems that have like these maximum type things in them, whenever you hear like maximum number or something, a lot of times, I wouldn't say a lot of times, but there's often the case with these problems where you end up using sliding window. So it's one of the things that have in your toolbox when you see maximum blank blank in a string or something like that you may, or an array or something like that you might have to use sliding window. And that's how these algorithms end up working out. You just kind of have to, you look at the problems, you start to see patterns, and you start to have your solution toolbox, and then you start to try it. Like in an interview, you might have to say, man, should I use this? Should I use that? Should I use this? And so anyway, I'm not going to keep talking about that. I know here I'm probably going to try to use the sliding window technique, and I'm just going to basically like I did, like I'm going to look at 3, like these, 3 at a time. In this case, I'm going to look at 2 at a time. And then in this case, I'm going to look at 3 at a time again. And I'm just going to count. I need to count how many vowels I have in each little window that I'm looking at. My 3 wide window, if that makes sense. And so, yeah, that's how you would do it. Now, the part why I think, like a lot of people on LeetCode was saying this should be an easy one. It's like if you know sliding window and you go study data structures and algorithms and you learn sliding window, a lot of y'all might come in the comments and whatever, and some people on LeetCode will say this is an easy problem. Now, I think it's a medium because to me, there's a lot more easy problems than this one on LeetCode and coding challenges in general. To me, it's a little difficult because coding out the sliding window is easy to get confused because like coding it out optimally. So when I first, let's just jump over to the code. Let's go ahead and jump over to the code. If you use LeetCode before, they already stubbed the function out for you. Now I know the first comment I'm gonna get, why use var here? LeetCode did this, so you ain't gotta say it. I did not put var here. LeetCode did this. So anybody that know JavaScript know that you probably wouldn't use var here in a real application. LeetCode did that, so I'm gonna change it to const. But yeah, I didn't do that. So anyway, LeetCode gives you like the function stub. Then they tell you what your parameters are. So we know we got a string coming in called s. We got a number k, which that's the size of our little sliding windows that we're gonna slide through the array. And we know that the length of s, the size of the string, is always going to be longer than the number of the width of the window. And then we need to return a number, which is the number of value, the max number of values that we see in the maximum number of vowels that we see in the substring of the given length. That's kind of what our answer needs to be up here. And I'll put this here for y'all to see, people that join later, whatever, they can see that. But I know I need to return this, so I'm gonna go ahead and just say like max. I'm just gonna call this max, and I'm gonna return it at the end because I know I have to do that. So yeah, so I'm gonna know I have to do that at the end. So I'm gonna go ahead and just have that ready to go, so I don't forget to do that. And so when I'm looking at this, like y'all know what I said I was gonna try to do. I'm gonna try to just loop. I'm basically gonna try to go through the string, which is, you know, how you do that is just a loop, some sort of loop. And I want to look at 3 at a time in the string. So the first thing I did when I started trying to solve this problem was I set a start pointer and an end pointer to kind of have my window. And then I grabbed the substring of the string at every window. And then I just looked through that substring and found every vowel and just counted the number of vowels. That usually when I do these lives, I go through the unoptimal solution. That solution works. Like you probably could even pass a interview with that solution. If they don't have you running it against a crazy amount of data, it would just pass. But once the data scales up, because of me using the substring function and having that has to loop through a string and pull out the characters it needs, somewhat loop through a string and pull out the characters it needs. It's not a cheap operation. And then me looking at each character to find the vowels over again every time is pretty expensive. And so there is a more optimal way to do the sliding window technique here. And that's why I think this problem is hard, because there's multiple ways to do the sliding window. You can loop through and get substrings out and look at the substrings, or you can kind of in real time slide through the window and keep a sliding count of the sum that you currently have. That's the hard part to me. That's why this is a medium, and it's not a hard, but that's why it's not an easy to me, because you gotta kind of keep the easy way to think about it is like, let me look at ABC. How many do I have? 0. BCI, how many do I have? 1. CII, how many do I have? 2. That's 2 vowels. That's not optimal though. So like the most optimal way to look at this is I start with A, no vowels, go to B, no vowels, go to C, no vowels. Now I know I'm at my K size because I have 3 things. And then here I want to add 1 here and take away 1 at the start. And when I add this vowel here, I want to say, okay, I want to add to my runningSum 1 because I found 1 vowel. And then once I move to the next place here, I'm going to have 4 then I want to add another vowel to my runningSum, but then I want to take this out, this B out. But if this B is a vowel, I need to remove it from the runningSum that I have. But it's not a vowel, so I just simply move this pointer up so that I'm only looking at 3 at a time. And then now I have 2 in my running total. And so then if I take away this last one and add this one, now I'll see the I here, it's a vowel, and I'll say my running total is 3. And so then when I go to the next one, I'm going to say this is not a vowel, so I don't add anything, but I'm going to take this one away. And now I need to subtract 1 because this is a vowel that I need to look at the thing that I'm taking out of my sliding window and subtract it from my runningSum. And so that's the part that I think is a little bit makes this a medium, because I'm not just recalculating the sum every single time. I'm keeping a running sum at all times while I'm sliding the window. It's really hard to explain without doing both versions of the code, but I ain't got time for that. It's 10:48, so I'm gonna go through the optimal solution so you see the best way to do it, and then you can go explore this on your own and try to figure out the ways that you want to do it, or explore the different ways to do it. But hopefully that made sense, like those two ways of doing it. So I'm going to do it the second way. And the second way basically requires me to keep what I'm calling I think I kept calling a running sum. So it's going to start off at 0. And then I said I was going to have like a start index. This is going to be the start. This is going to be the pointer to the start of my sliding window. So like that little window I was talking about, I'm going to be moving along. That's going to be the start of it. And then this part might be confusing too, but like if you see I have a start, then I'm going to need like an end index. And one thing you might do is you might be tempted to be like, I'm going to do, this is when I first did this problem, that's where I got confused. I said I'm going to set an end index to, my bad, it's going to be like K. And I think it's K minus 1 actually. And that will give you your first sliding window. But you actually don't want to do that because it makes it harder to keep like the running sum. It just does. Like it makes it really hard to do it because then you're like always keeping you're always having the window open from the start, and it's hard to get the start of your it's hard to explain, but it's hard to get the start of your running total going without like adding some special logic. Kind of hard. It's really hard to explain that part. But when you see the code, I think it'll make a lot more sense. What I actually want to do is put, this would be oh shoot, what is this? Oh, it's like my stream key. That's crazy. I want to put I want to have my end index here be here, and I'm going to say end index is less than length, and then end index. So I'm actually going to have my end index just be my loop iterator value or whatever. And I might have to actually make this smaller. So sorry if it's harder to see, but I need a little bit more space. So yeah, I'm going to have this end index be here instead of starting it off. And so I'm actually going to start with my sliding window like smaller than it was before or whatever. So basically this is going to loop through the whole thing, and my sliding window actually is going to start like really small, and then it's going to like grow into like the size it should be. And then when it's the size it should be, I'm going to maintain that size of it. And I think that's one of the confusing things about the problem, is that you don't just start out with the sliding window size. You're trying to make an algorithm that can go through the whole thing basically with the same code. So yeah, so then when we get here, I'm going to have a starting index that starts at 0 and an end index that starts at 0. And the first thing I want to do is I want to look at what's in my end index. Oh, and you know what I missed? The big part I missed is, and I'm not going to say I missed it, but the first thing I need to do is I want to compare the first thing that's in my string. I want to compare it to check if it's a vowel or not. And so how I can do that is I can create a set. And so this is probably going to be the most performant way to check if something's a vowel or not, because you want to be able to do that in constant time. You don't want to have to search a string list. And that's one thing that can trip somebody up in an interview and make your algorithm slower. So like you might ask, like, why not just and this is the JavaScript set. Basically a set contains unique characters, and accessing things and checking if something is in the set is a O of 1 constant operation. It's a very fast operation. Now, let's say I just wanted to have this be an array. checking an array for a character is a more expensive operation. Like it could, like let's say I was checking for you. When I write the code to say like find you, it's actually going to, it's not going to know these are unique. So it's actually going to go and look through every single one of these. Worst case, you have to think about the worst case. To find the U, it will go through all of these. But when you have a set, these are guaranteed to be unique. This will throw an error if these are not unique. And me trying to so then that means when I try to look in here and see if there's an item here, it's big O of 1 or constant time. It's a very fast operation that'll keep my algorithm at the proper time complexity that I want it to be. So I need this to use. So basically I'm going to say in JavaScript, the set has a has function that you can check. Does the set have what I'm looking for? And what I want to look for is in my string s at my in index, does it have, is my in index basically the in index is currently where I'm at. It's what I want to check right now. That's what I want to check, that to see if it's a vowel or not. And then if it is a vowel, then I want to update my runningSum because I found a vowel and I want to just do plus, which will just add 1 to it. I got some in my runningSum. So now I've already kind of started my progress of having like this runningSum. And so then the next thing that I have to do is, as I'm adding this runningSum, this will eventually grow. And this is kind of the hard part to think about. Like, I think you literally have to just like practice writing sliding window algorithms to kind of like get this part. But basically, I need to check the size of my window. The window can be less than or up to the size of the K, which is the maximum size my window is allowed to be. So basically I need to check to say in index, the size of the window. So in index minus start index, obviously the start index is here, the end index is here. So if I subtract them, I basically get like the distance between them. And I need to check if that is equal to K, because I need to know if my window has hit its like max size. But I actually want to know if I'm at the end, like if I'm currently at the max size and adding one more or whatever will push me over my max size, and I need to basically subtract the first thing out of the sliding window. So I actually have to add 1 to this, which that part can trip you up too. But I think if you get to the end of the algorithm and like you feel like this number is off, then you'll know to come and add a 1 here. Like the +1 thing, that's where like that can trip you up so bad in interviews sometimes, like being like 1 negative off or 1 plus off. But here it's just basically how the math works out. I need to subtract this and I need to add 1 and check if it equals to K at this point. And if it does, then, so what is the first thing? Now I got to think about it. What is the first thing I want to do if this is equal to K? So I know one thing I need to do, like I said, is start index. I need to increase that because I know that I'm at the end of my sliding window. And I know when I go into this loop again, in index is going to be added to. So I need to move up start index to kind of keep up with it, but then keep my sliding window at the right size. So I know that needs to happen. And then the other thing I said, remember I'm running this sum here. So if I determine that start index, before I add to it, if I determine that the start index that I'm leaving, so like let's look at start index let's look at S, what character is at start index right now. If it's a vowel, so I need to check the vowels set. If it's a vowel, then I need to subtract from my runningSum. And so this is the part where you're basically keeping your runningSum in the right place. I'm adding to it when I see a vowel, But then if I'm moving my start index and I'm leaving a vowel, like the start index used to have a vowel in it, or it has a vowel in it before I move it, then I need to remove that from the running sum. And then here, now I remember what to do here is we can't forget about this max here. So once I get here and I know I'm equal to K, I know I have a window that's the proper size that I can test whether or not how many the maximum amount of vowels I have. I can basically say I need to check if math. This is an opportunity for me to check if my running sum has now gotten, because I've added to my running sum here, and now this is the opportunity. Once I know K is the right size, it's an opportunity for me to check. Math.max in JavaScript will just basically take the highest of these two things that you put in it. And so I can see if my running sum is higher than my current max, and I can set it to my new max. And so max will always just have the maximum thing that you get by the time you run this whole algorithm. And so now I'm seeing that now I got this set. It's always keeping the highest max here based on the running sum and based on the old max. And yeah, after you get out of this, then you'll just keep looping through till you get to the end of the array. And by that time, you should have max, because you keep finding the max of max and running sum. You should have the proper max, the maximum number of values in the substring of the given length at the end there. So I hope that makes sense. I'm sorry I'm not reading comments and stuff. It's hard to read all the comments and stuff and try to do these things at the same time and keep your thought process going. But yeah, I see some people jumped in and said, "What's up?" My boy Darius, Photo Logic, what's up, man? I know some people got some comments and stuff like that. People saying it works the same way in Python. Yeah, it definitely should, just different syntax. Some people don't use JavaScript, so they don't know. Understandable. Cool. Which product or tool has the most trash docs you ever seen? I'm gonna answer that after I get done for sure. But anyway, let me try to finish the problem, and I'll probably answer a few questions. But anyway, yeah, this is looking good to me. So usually what I do here, I'm probably not gonna do it this time, but usually what I do here, if you're in an interview, some companies actually won't let you run this code. Like, they will make you trace through it line by line manually to make sure that it's working. And they will make you prove to them without running code, because some companies don't really care that it's absolutely 100% working code. They want to see how you think and how you troubleshoot and how you kind of look at code and how you line by line diagnose code. So that can help you find issues too, going line by line. Some companies they'll be using like HackerRank, or they'll be using their own internal thing, but they'll actually have a runner that'll let you run the code, and they'll let you debug and put in console logs. So be prepared. Always know how to debug your code by hand, and not, I mean that metaphorically. So don't always expect they're gonna have a runner where you can put console logs and stuff in. I've had a lot of interviews where I had to prove to them, but it can be to your advantage, because you might not even have the right answer, but if you explain it well enough to them and make them think that it works or it seems reasonable enough, their goal is not that you have to get the right answer. Their goal is, how are you thinking about the problem? And so I'm not going to go through and do that, but I am going to run through line by line as a summary. And this is kind of what you would do as you're talking to an interviewer. So here, I set up a set of vowels. I use const because this is never going to change. And A-E-I-O-U, that's right from over here. So just double checking. A-E-I-O-U. I'm going to set my max to 0. That's going to change. So I'm using let because I don't want it outside the scope of this function. runningSum is going to start at 0. Start index is going to start at 0. My end index, of course, is going to start at 0. Which, yeah, that's the kind of confusing part, that we're going to kind of build a sliding window from 0. And then we're going to just loop through the string using the end index, actually. And then if we're going to use the has function on the set vowels, we're going to check if the current value in our string that we're currently iterating through, is it a vowel? If so, we're going to add to our runningSum. So as we're moving the window, the back of the window along, we're adding things that we find, vowels that we find. But then here we're closing the window and we're calculating, we're closing our window up, but at the same time, we're calculating what the current max is. So if end index minus start index plus 1 equals k, so that means we have a window, we have a right size window, it's 3 or 2 or whatever k is inputted in here. Then we want to check the max of the runningSum. So all the runningSums we add, is it the maximum? So is it higher than the previous maximum that we ever gotten before? And this will just keep, this line of code will just keep making sure we always keep the max. And this is a constant operation. It's just like an if statement, basically. It's just a quick way of doing an if statement. So yeah, that's one thing too. Know like if you're going to use substring or you're going to use these built-in like functions, know what the time complexity of those are, because the person might tell you can't use them, and if you do use them, they're going to ask like what the time complexity is of your solution, and you better know what these built-in functions are doing, because otherwise they're going to be like, well, how do you know that's not optimal? And that's where people get tripped up usually. They usually use some sort of built-in function, and they don't realize that built-in function, every time it runs, it's like big O of n, it's like linear time. They have it nested in another loop, and so now they're running at like exponential, n squared, big old n squared time, and so it's like actually not a really good solution because of that. So anyway, next thing I'm gonna do is check this part of it. These two lines basically are closing. They're the logic to close, to not close, but to like move up the front side of my window. So I know that my window is about to be too long once I get to this next loop. So here I basically say, okay, I'm about to get rid of my last start index, but before I do, let me check if it's a vowel. If it is a vowel, I need to take it out of the runningSum. I need to remove run from the runningSum, and then I'll move my start of my thing up after I check that. And so that's basically it. Then once I loop all the way through and get through everything, then I just return the max. And remember, the max is always going to be the highest thing here. So I explained that. Without further ado, since I'm on LeetCode, I ran through the code here. I think my code looks good. I don't see any bugs. So I'm going to run it with LeetCode. But I could have bugs, so we'll see. I'm about to run it. So I'm running it basically right now on these 3 test cases. Oh, I knew that was a bug. I don't know why the heck. I literally looked at that right before. It basically said I got an extra semicolon there. I looked at that right before, and I don't know what language I got that from. Some other language I was using recently, maybe. But you don't need a semicolon at the end, which is kind of like inconsistent to me. It's like I need a semicolon for this, I need a semicolon for this, but then this one I just don't. So that's one thing always feels weird to me. But I jump around different languages sometimes, so I get confused. So anyway, that was the little problem with that. What LeetCode is doing here, when you just run it like that, it runs test case 1, 2, and 3 that are basically from over here. So like this one had the 3 eyes, so I should get the output of 3, which, well, I guess I don't have to look over here. I can just look right here. So yeah, I should get 3 in this case. I got 3 as expected. For this one, A-E-I-O-U, I should get, if the window size K is 2, then the only possible thing I can get is 2 as the max. And then for that LeetCode one, then if the window is 3, I can only possibly get at maximum 2 vowels in that substring size of 3. So yeah, this one, I think this problem, it deserves to be a medium. I know a lot of people was down in it like it's an easy one. Yeah, if you've been doing a lot of these, yeah, it's pretty easy, but it can definitely trip somebody up in the interview, because the question itself has a lot of, you need to understand. It's not the simplest question in the world in the first place. And then slide in the window, man, it's easy to, like, if I simply just forgot this +1 here, which I've done before, the whole thing wouldn't work. If I just thought that the distance between end index and start index was equal to k and forgot this, it wouldn't work. Or I didn't add it somewhere else. Like, I had to take care of that one at some point in the algorithm. So anyway, the next thing, big old complexity. The interviewer will make you talk about that. So Let's talk about the time complexity. Big O basically is a way to notate the time and space complexity of your algorithm, the performance that it will have based on scale. And the scale is based on your input. So our input here is the string S and the K here. And so really the main part of the input is K is kind of like arbitrary, I think, because K will always be less than the size of the length. So you can kind of like roll it into, I think you can kind of roll it into the length of S. And so I think the size of our input, like if we had a string with 1,000,000 characters or a string with 1 character, I think that's where our input size can be drastically exponentially changed. And so the big O notation needs to work off of that. Let's call that N. So let's call S length, let's call it N. Or should be like N equals this. And so in big O notation, a lot of times you use N. And so what are we doing here? So we have, all right, N, which is the length of this string. This set is AEIOU is 5, so that's constant. It's not tied to the size of our input. All these are not, like, no matter if we have 1,000,000 characters or not, these things will always happen the same way. It doesn't matter how long the string is. These will always happen the same. So they are negligible in our big O calculation. This is where it changes. This is where it switches up right here. So, because it's using the length of the string here, which we called N up here. So we know at the very least, if this is 1,000,000 length, we're going to have to loop through this 1,000,000 times. That's directly correlated to the size of our input, and that's where big N time complexity comes in. So we know we at least that big O of N, and that's linear time. Linearly, if we have 1,000,000, we're going to loop 1,000,000 times. We have one string character, we're going to loop 1 time. So that's linearly tied to it. Other than that, what are we doing inside of here? Are we doing anything inside of here that is scaling with the size of our input? Yes, we're calling this multiple times, but is anything exponentially going on inside of the loop? I don't think so. Like I said, I made a big deal about using the set earlier. So this is a constant operation. We won't have to worry about it. Constant operation. If statement's a constant operation. I talked about this earlier. Math.max is a constant operation. This is another using the set again. Constant operation, constant operation, constant operation. So everything in my loop is a constant operation. So I can kind of just roll this up to just being just this whole thing is just big O of N. And so everything that's constant operations just gets kind of swallowed. I hate to say swallowed up. Gets swallowed up by the big O of N time complexity or whatever. So it basically is negligible. So you just kind of like reduce it in the formula for your big O thing. So, and then yeah, of course this is just constant. So really it's just big O of N. Everything just reduced out. And then space complexity is the same concept as time complexity, but it's how much space are you using. And so as far as like data structures I'm sorry. And so the only data structure we're using, and it doesn't count the inputs, but the only data structure we're using in our algorithm is this set, but it's a fixed size. Like no matter how big our input is, it'll always be AEIOU. The vowels will never change. So they have nothing to do with our input size. So they're negligible, they're constant. And anywhere else, I'm just setting constant variable, like these simple variables. I'm not really doing anything. Like I'm not creating a map or something with 1,000,000 things in it. I'm not creating another array with 1,000,000 things in it. I'm just simply operating on the things I already have. So my space is actually pretty simple. It's just constant, big O of 1. And so, or you can call that constant space. And this is called like linear time or whatever. So yeah, so that's it for that one. The last thing to do is LeetCode has this thing where you can run your algorithm against, they got a bunch of test cases that have like 110,000 characters in it, like a bunch of test cases that cover different edge cases and stuff like that. You can run it against all their edge cases, and you can run it against other people on LeetCode and see kind of how it stacks up. But you gotta take that with a grain of salt. Like the calculations change every time you run it. So I'm gonna do that. I'm gonna run it here. See what happens. Yeah, so saying I need to start a study plan. I want to do that. But yeah, so I got the right answer here. So it beat all the test cases. I think it says I beat 85% in runtime and 76% in memory, which is pretty good of other people that did this problem before. But this thing, you run this again, it'll change again. So this ain't really real to me. But I'm just glad it worked out as far as the beating all the test cases. And then they let you run this little time complexity thing. So yeah, like I said, time complexity is big O of n. And I hope the memory complexity, yeah, big O of 1. So looks like I was right on that. Yeah, and that's it. That's basically it. That's how you do the problem. I'll go back to the description over here. Actually, I'll go back to the code since I already got the thing written here. And yeah, this is it. So yeah, I appreciate y'all watching and checking that out. Like, that's how you do this problem. It's called maximum number of vowels in a substring of a given length. It's a medium. I'll check out a few questions now if anybody got them. And I'm sorry if I missed your questions earlier. I can't sit here and I can't do the questions and I can't do this leak code question and try to answer the question at the same time. It's too much mental stuff. Now I can do from like one person, like if it's the interviewer or something, but it'd be way too much to try to keep up with it. So let me see. If anybody got any questions or whatever, why use a set if it's constant already? Why use a set if it's constant already? I don't know what that means. It's set as a constant because it's not going to change. The constant doesn't have really anything to do with the data type I'm using, but I might be misunderstanding the question. So appreciate it, man. I see my cousin Chris joined. What's up on Instagram? What's up, man? If you still on here. Why do you stream and how long did it take you to get this good? Oh man, it took some years. And I don't feel like I'm not even, like, I got ways to go. I mean, I did get to the point where I could pass some FANG interviews and pass some smaller company interviews. So once I got to that point, I was so proud of myself. But it took probably, I had been in the industry working for like 10 years already anyway, but I really wasn't doing leak code, like coding challenges. So it was a whole different skill. I'd say it probably took like 4 or 5 months to get to a point where I could pass interviews, I'd say. But that's after having experience. If like you're newer, like I think it could take you up to a year. Like if you're new to the industry, new to learn how to code and trying to get your first job, you might need to study for like maybe 3 to 4 months and then start doing interviews. And then it could take you, like you might have to really go through some interviews. It could take up to a year. Now, some people have done it faster, like, so don't think that that's not possible, but I'm just saying, just be prepared for it to be a year. Would you recommend buying a Mac? Yeah, like I use Mac everything. For development, Mac is like king. Like most companies, even developers at Microsoft use Macs. Like, or at least maybe some of y'all from Microsoft, maybe y'all don't know more, but I definitely seen some people that work at Microsoft using Macs that was developers. Because Macs have a good development environment. At least to me, it's more conducive to developing. And plus, I do iOS apps too, so it's like I have to use them. You're the GOAT for providing this kind of content on TikTok. Hey, appreciate that, man. You gotta get something different on TikTok, man. It can't be all this dancing and I'm just playing. Hey, you do what you want on TikTok, but we gotta have a space for stuff like this too. You know what I'm saying? It's good to have a variety of content on here. So I'm just trying to get on here and, you know, help people get in the industry, help people get new jobs, help myself. Like this helping me. Like talking this out to y'all and practicing these problems helps me a lot because it's like the similar type of skill that you need to do in an interview. So it helps me and it's just fun, you know, just talking to people on here. A lot of good people on all these different platforms that's into tech and into like programming stuff like me. So Why use a set of numbers? Vowels is already constant time. Why use a set of Why use a set for the vowels? Because you need to be able to access. So like right here, I'm checking if what I'm currently looking at is a vowel. You need to be able to check if it's one of these 5 things. Now, if you do this wrong, if you say, is it an A? Is it a E? Is it a I? Is it a U? Is it a O? Then you it's a more expensive operation. Now, I think I see what you're saying though. You're saying like it's already constant, like it's only 5 things in it. So that's a good point. Like you really don't have to have a set. You're making a great point. Actually, I see what you mean. It was hard to understand how it was how you said it, but you said it right. Like, yeah, I get what you mean. I would just say that using a set is still faster though. Like it's like one constant operation. Worst case, if I don't use a set, then I have to check all 5 of these to get to the 5th one in the set, in the array. If I use like an array, for example. But you're right, because it's 5 vowels. It's a constant. It's really small. It's only 5, so it's like, yeah, you really don't need a set. But more or less, I'm trying to like, this could be much larger. This could be arbitrary. The set could be 1,000,000. It's, not in this problem, but I'm talking about in a different problem. So I'm really trying to teach the kind of concepts of like big of one constant access to a list when you're checking for stuff. But you're absolutely right. I did not have to use the set. So I see what y'all were saying. Now I appreciate y'all bringing it up because that made a lot of sense once I thought about it. Real life, an array will be faster, but it doesn't matter. I mean, I guess, I don't know. I think a set will be, I guess it depends on how long, if the set has some sort of like, I don't think so. I feel like the set would be faster because the access would be faster because it would be just that everything is unique in the set and it'd be keyed and you'd access it immediately fast. But searching an array is going to be, the array is not going to know that each value is unique. It's not going to be keyed. It's just going to look through. It's going to have to literally search through the whole array to find what you're looking for. So, but maybe I'm wrong. I could be wrong. Like I have been wrong on here before, for sure. You have to read up on var, let, and const. Hard to describe with the comment. Yeah. So yeah, like I think, like if you're new to JavaScript or you don't use JavaScript, most languages have these different, I don't even know what you call them. What do you call them? I'm forgetting what the heck you call them. But like var, lets, and const, basically like is how it's showing you or it's telling the algorithm or program what the scope is of your variable and whether your variable needs to change or not. So const, or it stands for like constants. I guess it's short for constant. And it's always going to be the same. So if I tried to change that vowel, it would throw an error and it would protect my program from me doing stupid stuff that I didn't mean to do with that variable. Var is, it's hoisted. So var variables, if I put this as a var, then it would actually be hoisted outside of the function and I can use it outside of this function, which is usually frowned upon because it can make your code unpredictable, because like I may have vowels inside this function, I may have vowels somewhere else, and it can lead to like the variables that I thought were supposed to be separated getting mixed up. And then let is usually what you use. It's scoped within your block. So the block is usually with the brackets, a function or an if statement or whatever your block is at the time. And it scopes, it doesn't hoist beyond the block, and it's able to be changed. So it's kind of in the middle between a const and a var, but then the const is different because it's, and I don't know if is const hoisted. Y'all let me know. I don't know if const is hoisted or not. I know var is hoisted, so, and it's able to be changed, but I don't know if const is hoisted though. But I know const is not able to be changed. So if you're a JavaScript dev, just let me know. Access modifiers, yeah, I appreciate that. I couldn't get the freaking name in my head for some reason. Thank you. Appreciate that, man. See, that's why I like being on here. It's just a lot of great, smart people on here. You wouldn't think, like, you know, when I first started getting into programming, like this was like 10 years ago, it was like me, man. When I was in college, it was like no one even wanted to do this type of career. Tech wasn't that pretty. Like in college, our building was super small. Like it wasn't like people weren't really excited when you said what you were doing. But now it's like huge. And so I started coming on social media probably like 5 years ago or so, maybe a little longer. And like just seeing how many people are on here trying to learn, get into tech, different parts of tech. It's pretty cool, man. And the relationships I've been able to build on here and the people I've actually been able to meet at conferences and stuff like that, and even getting job offers or opportunities. I mean, yeah, it's worth it, man, to be on here and just kind of, if not the very least, get a different perspective of what we all get put in silos in our lives. And so that's a one double-edged sword. That's how social media is a double-edged sword. Like you can get a lot of advantageous stuff out of it, but you just got to kind of avoid the unhealthy parts of it, of course. But like there's a lot of good stuff for tech on here. You guys got LinkedIn. Yeah, everybody, if you see other people in the chat, like follow each other and stuff too. Like hit each other up, DM me if you have questions for me beyond this live. Follow and stuff like that. DM me, whatever. If you DM me, I'll pretty much follow back. Like if we have a conversation, then I follow you back and try to follow what you're doing. I want to learn to make something you're interested in. I start with prime number gens. Was that the problem you started with? Assign primes to the letters and get the product of the primes representing the. Yeah, you getting deep on that A-E-I-O-U. I see. I guess, man. Raymond. I get, yeah. Yeah, you could do that. Get deep on that. Python. I see what you're trying. Yeah, a way to get the. Let's fix this for loop. If you want to make something you're interested in, I'm just reading comments. NeetCode, yeah, NeetCode is a great resource. I lost NeetCode. I need to get back on NeetCode. I'm sorry. It's like a list of LeetCode problems to do. Some of the top ROI, like return on investment, as far as the problems to do. Because you don't want to just do a bunch of random problems. You want to do problems that companies are actually asking, and the problems that will help you learn how to solve other problems and help you learn the foundations. One thing I did was use Algo Monster. I know everybody loves Algo Expert, but Algo Monster is a beast, man. Algo Monster is like, and I'm gonna show this while I'm actually gonna make a post about this. Algo Monster, and I know y'all barely can see this, but Algo Monster is a site that helps you learn how to do these, and they focus on the patterns that you need to learn. So they focus on all these different patterns. Like the one I did today should be in here. Oh, it's not in here. It's not like a major one. I think it's like a sub problem of 2-pointer. But sliding window, I think it's a sub pattern of that one. But basically, and why is it showing this? I'm not even logged in. But anyway, it'll show kind of your progress here, but like they have all these patterns and they have it based on ROI. So like the ones that show up in interviews most, and they tell you to learn in that order, and they teach you the data structure. You need to learn how to do a backtracking algorithm, how to do a two-pointer algorithm, how to do a binary search. Those algorithms, you need to know how to do those like the back of your hand when you're getting interview ready. So like if I'm not even interview ready, I'm just doing these just to kind of stay kind of warm. But like when I was interview ready, like when I was actually actively interviewing, I had every single, or not every single, but I had the top ROI algorithms memorized, because you don't want to get stuck trying to do binary search if only a small part of the problem is binary search. Like you want to know first of all, your coding language you choose, you need to know the syntax like the back of your hand. Like you need to know how to do everything in that language. In the sense, you can't get stuck on stuff like that in an interview. You can't get stuck on like how does substring work, or how does math.max work? How do I find the max of something? Or how do I set a new variable? How I do a loop? How do I do a while loop versus a for loop? If you get stuck on that, you need to stop and go back and learn the language more. And then if you get stuck on these algorithms, like you should know how to do breadth first search and depth first search. You should know how to do a basic version of those algorithms. Now they'll be adapted for the problem you're doing, but you should know how to do a basic one of them from the back of your head. Like if you have a graph, like you should know how to traverse that graph and look at all the sides of each cell, around the cell, and how to go to different parts of the cell and basically search through a graph problem or whatever, or a map problem. So it's like you need to know, or like a binary tree, you need to be able to do like a binary search. And so like the problem's going to be harder than that, but knowing the basic algorithms, memorizing those, that's where the memorization comes in. You don't memorize a bunch of solutions, but these patterns, you memorize them. And so that's what, I'm going all over the place, but that's where AlgoMonster like shines. Like they teach you these patterns first and you drill them into you. And then by the time you start doing problems, you're like, dang, that's this pattern. And you start to see patterns between the problems. And then you start to, when you get in interviews, you start to like have this wheel in your head of like, okay, which one of these can fit this problem? And literally, I got stuck in interviews before, and I literally just started going down the list with the interview. I was like, man, I think maybe I could use 2-pointer here, or maybe I could use backtracking, or maybe I could use, like, I didn't say these exact things, I'm just giving an example. Like maybe I could use binary search or sliding window. Like, and sometimes the interviewer, just hearing you say that, sometimes they'll literally help you. Like, man, that 2-pointer thing sounds interesting. Like they'll do something real slick. Sometimes if they're nice, they'll do something real slick to help you, because a lot of them do just want to see you get through it. They don't want to sit there with you struggling. Like they really do want to see you get through it. And so sometimes if you just literally just like ponder on stuff, like they'll be like, hey, so so that 2-pointer thing, go a little further with that. And that's like that's them giving you a hint. And then you're like, okay, I memorized how to do 2-pointer. So worst case, if I memorize how to do 2-pointer, just the plain vanilla algorithm, worst case, I can at least get that far in the interview and adapt it. And then you trying to adapt it to whatever they're asking you to do. That's the hard part, And so anyway, like they got another cool thing on here too that I'm going to make a post about one day. Shoot, I don't know if I can find it. It's this thing. Yeah. The flowchart. This is new. Like since I've been using, I haven't been to I haven't been interviewing in a couple, maybe a while, like actively interviewing. So I haven't been on AlgoMonster, but they actually made this new thing, like this map. This thing is cool because it's like, remember I was talking about the patterns and like going down your list in your toolbox of depth first search or topological sort or Dijkstra's or whatever the case is. This thing helps you with problem and pattern recognition. So once you do a lot of these, you'll start to see that like I said when I was solving this problem, that like I saw like it said maximum. Like whenever you see a problem, a lot of problems will say find the maximum sum out of blank blank blank. And so like that'll help you. You'll start to see that a lot of those problems with the same wording in them will have the same approach for the solution. And so this thing is basically giving you a flow diagram saying, is it a graph? Yes. Is it a tree? Yes. Then you need to do depth first search. No. Is it a problem directed to acyclic or acyclic? I'm sorry, I said acrylic. Acyclic or whatever graphs. Then you use a topological sort. It's crazy. These problems are kind of hard, but like I like them though, because I don't know, man. They just always they're more interesting. They more feel closest to like some real thing you be trying to do. But I'm just kind of going off to the side with that. But basically, man, I'm not going to go through this whole thing. But like it basically tells you, it points you to like 2-pointers if it has linked list or something. Or like, I don't know. It just gives you like a path to follow mentally to solve these problems. If you can somewhat get this kind of, you probably won't memorize this whole thing. It's not good. But eventually you'll have part of this in your mind, and you'll be able to kind of look at problems and like start leading them toward one of these purple solutions. And so I think that's a cool thing that they added here. But anyway, I'm gonna come up off of that, and yeah, I think I'm probably gonna end it here. Probably gonna go play the game or something. I feel like I done got my programming in for the night, so probably go play Xbox or something. I don't know. Anybody got any more questions they want to ask? I'm sorry if I missed stuff. I suck at doing this. What company you at? Now, I'm at this chat company called Live Person. They do chat for a bunch of big companies. So like if you go on like Verizon.com and chat, do like the web chat, like, hey, can I chat with a customer service? Like, we provide that box that's there. It's like white label, so it looks like it's theirs, but we actually the ones that make it. And I actually work on the actual chat box. I'm not gonna say no more than that about the job. It's a cool job though. I like because I get to see my stuff out using it. I get to see people using my stuff, and as well as I get to use it myself. Like, I'll just be like going and do some customer service thing, and I'm like, oh snap, this is our thing. So that's one of the coolest things about being like in software development, is like actually seeing your stuff being used. That's what I like. Some developers don't care about that, but I like that, man. Like, that's a nice bonus to getting paid, you know, like being able to like be like, dang, I built that, man, and like millions of people are able to use that and see that. Like, that's dope. So anyway, Stripe makes great engineers, perfect place to learn. Yeah, man, I try to interview for Snipe. Not Snipe. See, I'm thinking about Call of Duty, man. I think I'm gonna play Call of Duty, but I was trying to interview for Stripe, and shoot, I don't even know where it went. I don't think I passed it though, but I wanted to work there. Where did you go to UHD? Is that like school? I went to a private university in Georgia called Mercer. Like, it's not too well known or whatever, but it's not like super small and nothing like that either. So decent school. I liked it. I had a good time there. Got a good education. So got a computer science degree. Thanks. It's my first big company. Oh, you're at Stripe? User 66 something, whatever. That's cool, man. Definitely would love to work somewhere like that one day. Backend SWE. Y'all hiring juniors. Are you front end, back end, mobile, or full stack? So I would say like the last couple years I've been more front end, working on like kind of the chat window where the users use. I've been enjoying that because like it's very visual. Like as far as like customers getting able to see what I'm doing. When I first started at the company, I was doing more full stack though. I was doing everything because we were like in a smaller company. And shoot, man, I was making data. We would do everything end to end, which was super cool for learning. We would build the database that we're going to use. We would design the database that's more like it and like optimize the database. We would build the data models that we're going to use. We build the web APIs to get the data and like manipulate the data. We would build console applications if it was like some sort of processing job or whatever. And then we would build the actual websites, you know, and like web chat or whatever the case was. Like, so we did everything end to end. So I was like full stack dev. And so based on my career experience, I still call myself a full stack dev. But recently, in like the last maybe 4 or 5 years, I've been more or less like front end. And like when I go interview, I've been doing more like front end roles. But I can do back end. Like I've done Java professionally, C#. In school, I've done like C++ and a bunch of other languages in school. PHP, which everybody hates, but I made a lot of my side projects I did in PHP early on. So I made money from PHP. I don't care what nobody say. I'm straight with PHP. And then JavaScript, man, is probably like my favorite language at this point, just because now that you can use it with Node and use it with Express on the back end, And I don't know, man. A lot of frameworks and stuff. Sometimes it's too many frameworks, but it's just a lot of cool stuff you can do with JavaScript. And it's just easy to teach it and learn it. And, anybody with a browser can just open up the console and start running JavaScript from day one. And people generally understand how a website looks and works. And so like JavaScript ain't a crazy jump. Now Java, you got to be running like Java Virtual Machine or the JVM or whatever. It's like a big overhead to set up Java and run Java code. You have to install stuff on the computer. But like JavaScript is you just literally run it in the browser. It's an interpreted language. So scripting interpreted language. So you literally just write it. And so with other languages, they are not interpreted, they're compiled. You got to have some sort of compiler and a setup and an environment to run the code in. And so they're great languages. I'm not down in them, but I'm just giving the props to JavaScript because I like JavaScript. But C#, man, that's like my second love, man. C# was like, I did so much stuff in C#. Strongly typed, object-oriented language. Like, it's very scalable. It's way more scalable than JavaScript. I'll give it that. Like JavaScript, unless you're using TypeScript, which that's kind of where the whole, that's why TypeScript exists from one point, is to add like types and strong typing to JavaScript. But C# already was just like that. And so I love C#, man. That's where I learned about like OOP concepts, and we built a lot of, it's cool like building interfaces like, and classes and inheritance and like doing all this OOP stuff and actually seeing it really get used. Like one question I used to ask in interviews, and I'm just rambling now, but one question I used to ask in interviews is like, why would you really use an interface in real life? And so hearing people answer that question or not answer that question was always super interesting to me. And so if you know what an interface is, it might be interesting to you too. But yeah, that's why I like C#. It's just C# like this might hurt some feelings, but like, I'm not even gonna say that. I love Java too, but I'd say C# is like, C# got the advantage of being built after Java. So it's like Microsoft just copied Java and made it like they wanted to make it. I'm not gonna say they made it better, but they made it like they wanted to make it, and it's less verbose, less boilerplate code. I love C#, man. Somebody said Kotlin ruined Java for me. Man, you like the third person I heard say that. So I'm really haven't been on like any Kotlin stuff. It's mostly like been Java and Spring framework that I've used like professionally. But like, yeah, so it's all the good parts of Java and the JVM. Oh, so you're saying Kotlin ruined Java, so you only use Kotlin. That makes sense. Dang, that's pretty cool. The good parts of Java and the J. I'm gonna check that out then. That may like swing me. Laravel is low key go. Laravel been making a comeback, man. Like the last 2 weeks, like PHP and Laravel, like a lot of people been talking about that. But see, it's crazy how like cyclic the world is, because like everybody hated PHP, moved away from it, moved to Java. A lot of people moved to JavaScript, and then now JavaScript's doing like back to server-side rendering stuff. Like there's a bunch of React components and server-side render components. Or server components, I'm sorry. And so now people are like, hey, maybe PHP wasn't so bad. And so now people are like going back to Laravel, which is pretty cool to see. TypeScript is greater than JavaScript. Yeah, I mean, that's what it always comes down to. The TypeScript versus JavaScript argument that people argue about all day up and down. I love both of them. Like I don't think you always have to use TypeScript, but I think there are times when you really need to use TypeScript, but I'm not this like all or nothing type thing on it. Like I think there's a lot of projects, if you manage them well and do it right, that you can just use pure JavaScript too, if you know what you're doing. But yeah, if you're using a bunch of data models and stuff, and it's kind of no-brainer to just add TypeScript in there so you can have some strong typing and avoid issues and not knowing what your data is, unexpected issues with your data models and at runtime. So yeah, I don't see the purpose of learning Java until I learn Spring Boot framework. Yeah, yeah. I mean, there's other purposes because you got like Java's used with Android, but then I think it's moved to Kotlin now, I guess. I don't know. I started using React Native, so I stopped doing native. I did like native Android development for like one app, and then I just built this quick app with it, and I just kind of left it alone. But that's when it was like pure Java, and so you can use it for that. Yeah, mostly at work it's been like Spring, using the Spring framework to build like APIs with Java. So outside of that application, shoot, where else do you use Java? Where would you use Java without Spring? On Android? I don't know, man. Yeah, I mean, I guess maybe for like, I don't know. Maybe for like a console application you're building, maybe. I've never built a console application in Java. It's only been APIs, like RESTful APIs, and Android apps. So I don't know. It's a good question. Data applications, yeah, like some wrapper around a database or like a console application. Yeah. Lots of GUI stuff. Yeah, I remember in college using Java to build like a GUI, like some sort of app. I'm boring. I love Python. Python's great, man. I've never actually done Python before. I've just never got to it, but I need to. Yep, Node and Express. Yeah, I love Node and Express, man. Like a lot of people at work, when they stop using Java and Spring for the APIs, they start using Node and Express because you could just build so fast without like a lot of boilerplate code and all these like manifests and stuff you gotta set up in Java and all the dependency injection you gotta set up. It's just like you still set it up you should be setting it up in Node and Express, like to make sure you it's testable, but it's just a lot less boilerplate in Node and Express, man. And then you can throw TypeScript on top of it and you get all the strong typing stuff. So, and you can use classes in JavaScript. So, it's got a lot of cool stuff you can get with JavaScript that you had in other languages now. Somebody said C is better than JavaScript. I never used C. The lowest I did assembly in college, and that was like the lowest level language I went to as far as closest to the machine operations. And then probably the programming language was C++. Like that was probably one of the lowest I went as far as actually building stuff, real stuff with it. Type coercion is fun in JavaScript. Assembly is turbo hell, yeah. Assembly that was like a school thing, man. Like doing those like go-to statements. Like you don't have no loops. I don't think you have no if statements. It's all just like, I don't even really remember it that well, but I just remember like you don't get all the nice abstractions we have in modern programming languages. We got to be thankful for them. Cause like I talk to some old school people sometimes, and they're like, man, sometimes they used to literally in compile language, you literally have to compile a language. Compile a project would take 15, 30 minutes, an hour. They literally go to lunch while their code is compiling. Or they would have to like write an assembly language or write in these other things. Like, so it's, we got a lot of nice abstractions that have been built over time. Like that's all this thing is. Programming is just constant abstractions over time. So like, and now AI is kind of like the next new abstraction. Unfortunately, or whether you want to say it's fortunate or unfortunate, it's kind of the thing that's coming. That's kind of going to be the new abstraction. I think that's going to be like that layer that